Okay, so first of all, everyone can do. After that, I will do. Okay, first of all, everyone try. After that, I will do. Okay, make it. First of all, everyone try. Then I will do. Okay. Now, today we will focus on nodal analysis based problem. Using nodal analysis, our motto determine I naught with the help of nodal analysis. Okay. So, you can do, everyone can do, try. Everyone can try, then after that I will do. Okay. Everyone can try, then I will do. Okay. So, first of all, everyone can try, then I will do. Okay. How can I do? First of all, if you see very carefully, according to nodal analysis, if you say nodal analysis, so apply simply nodal analysis. Okay. So what about first step corresponding to nodal analysis? First one, decide branch current. Okay. That branch current already given. That branch current already given. So we have taken that one is a branch. That current. This branch current is I1. Okay. After that, node voltage. Second one, second step, that is V1 and that is V2. Third step, one node as a take reference node. Means we have considered that one is a zero voltage. Okay. So if this one is considered zero voltage, take a reference node that is zero voltage. After that, apply KCL. Apply KCL at node. At node, which node? V1. Okay, incoming current how much? 2 milliampere. Outgoing current I0 and plus I1. Okay. What about I0? I0 basically how much? V1 minus 0. This one is V1 minus 0 divided by how much? 3 kilo ohm plus what about I1? I1 basically V1 minus 0. Current leave from that one. Current voltage source available. So minus terminal, so written is minus 3 volt divided by how much resistance in this path? That is 6. So that is 2. So 2 is equal to, take LCM, then we got 6. 2 V1 plus V1 minus 3. So 6 into 2, that is 12. This is equal to 3 V1 minus 3. So 3 V1 this is equal to 12 plus 3, that is 15. So V1 is equal to 5 volt. So V1 is equal to how much? 5 volt. Clear or not? Now next target is our motto determine I0. So simply, what about I0? After that we have focus on I0 is basically V1 minus 0 divided by 3. So that value put 5 by 3 milliampere. Okay. Otherwise you can say that 3.67 milliampere is the right answer. If anyone faced out, then tell me, sir, I have faced out at that step. Can explain. Okay, if anyone faced out, then tell me. I will explain again. Okay, if anyone faced out, then tell me. I will explain again. Okay. First of all, make it. First of all, make it. If anyone faced out, corresponding to any step, it's right or wrong, whatever way you feel, and tell me. Comment it, I will discuss again. So first of all, comment it, I will discuss again. Okay? Everyone can try. Okay? Okay, make it make it nodal analysis. If anyone face today topic nodal analysis. Okay. Problem of nodal analysis. Simple problem. Okay. Related to any if you face any doubt corresponding to nodal analysis, then tell me, sir. Explain that topic. That part I will explain. Okay. I hope so clear. Now I will explain again that one. Simply that question is given like that one. Our motto determine I naught. So how can we determine? Simply we have considered first what is the first step of nodal analysis. First step say first of all decide branch current. Here branch current and that branch current already given, that branch current already given. So that one consider branch current I1. After that node voltage. How many nodes? V1, that's that one node and that one node. Number at least number of 3 branches connected any connect any point, that's called node. Okay, so that is V1 and that is V2. Now third step, after that what one node take a reference node. So if this one is taken reference node means 0 voltage. But if you face, sir, why would you have taken 0 voltage? You can also take 2 volt, 5 volt, 10 volt. But your answer is not changed. Okay, but for simplicity point of view, we have taken 0 voltage. Otherwise, you can whatever with the voltage, but answer is not changed. Okay, but if you take 5 volt, 2 volt, then your calculation is complicated. Otherwise, that's why we have taken 0 voltage. Okay, so now next, fourth step, apply KCL at node voltage at node. So we have applied KCL at node V1. So incoming current, sum of incoming current, only incoming current 2 milliampere. Sum of outgoing current I naught and I1. So written like that one. Next target, what about I naught? I naught is V1 minus 0 divided by 3 kilo ohm plus what about I1? V1 sorry. V1 minus 0 and current leave from negative terminal, so minus 3 divided by how many resistors connected in this branch? Simply 6. So after solve, we got V1 is 5 volt and last our more target determine I naught, so I naught is V1 minus 0 by 3. Put this value, we got the answer. So if you want face any doubt corresponding to that any step, then tell me, sir, I face the doubt corresponding to that one. That step I will explain again. So I hope so clear all doubts. Okay, so we have taken another problem. Okay, so we have taken another problem also. So the next problem is here resistance. Okay, after that a current source connected like that one. Okay, after that is 4 kilo ohm resistance connected. After that a voltage source minus plus like that one, current source like that one. After that a resistance. After that one is plus and here minus. After that one is how much? 2 kilo ohm. Okay, now that one is 6 kilo ohm, that one is 2 milliampere, that is minus plus, that is how much? 12 volt. and that one is 4 kilo ohm, that one is 3 kilo ohm. Our motor determine I naught, and here plus minus 6 volt, and that is 2 kilo ohm. Okay, our motor determine I naught. Our motor determine I naught with the help of using here nodal analysis. Nodal analysis. Okay. If anyone faced doubt, then tell me. Sir, can explain again? So I will explain again. I hope so. Make it first of all. First of all, make it. After that, everyone try. What about that answer? What about answer corresponding to I naught? Okay. Our motor determine I naught. So first of all, try everyone. Then I will do. Then I will do. Okay. If anyone faced doubt corresponding to any step, sir, what you written here, then I will explain. First of all, try using analysis. If question say using nodal analysis, so using nodal analysis. Okay. I hope so. Everyone try. I hope so. Everyone try. I hope so. Everyone trying. Now, so look here. Our motto. What is our motto? Our motto. Determine that current. According to nodal analysis, first step, branch current. Consider here I1, here I2, here I3, here I4, here I5. After that, node voltage, here V1, V2, V3, and that one is V4. And after that, decide one node is a reference node, so that is 0 voltage. So this one is also 0 voltage, and that one is also 0 voltage. Okay. But what is our target? Our target is determine I naught. We have focus on I naught. I naught means V2 minus V1 divided by 3 kilo ohm. Means if you determine V1 and V2, then put this value, then we got I naught. Not focus on that part. Okay. So how can you determine V naught, V1 and V2? If you see very carefully, that one 0 voltage and that is V2. So what about V2? If anyone faced doubt, then back to the topic. This one is V2 and that one is minus plus, and here written like 0 volt. And that is how much? 12 volt, and that is V2. What is the meaning of that one? Basically, this one is minus plus, okay, minus plus 12 volt, and here plus minus 0 volt, and that is V2. And here, if you apply KVL in this loop, we got minus 2 plus minus V2, minus 12 plus 0 is equal to 0. So V2 basically minus 12 volt. Here or not? So V2 minus 0, this is equal to, if current, now look here, V2 minus 0, this is equal to, if going on here, so which polarity? Minus 12, so minus written. Okay, means you can write now V2 minus 0, that's minus 12. Similarly, same thing here, if you V1 minus 0, what about V1? Simply written V1 minus 0, if you apply that formula here, V2 minus 0, V1 minus 0, this will equal to plus polarity, so this will equal to plus 6 volt. So V1 basically 6 volt, and V2 this will equal to how much? Minus 12 volt. Okay. And what about I naught? I naught basically put here V2 is how much? Minus 12, and V1 is 6 divided by how much? 3. So minus 6 milliampere is the right answer. Simple. Minus 6 milliampere means what about direction basically? Here V1 to V2. I naught direction basically from V1 to V2, not V1, V2 to V1. Because why? Because I naught is minus 6 milliampere. If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt corresponding to that question in any step, then tell me, I will explain again. Simply. Okay? What is our motto? Determine I naught. So we are focused on that voltage and that voltage. So next, first target is determine V1 and V2. So we have focused on V1 and V2. Okay? I hope so clear. If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt corresponding to any step, then tell me, I will explain again. Okay? I hope so. All doubt clear corresponding to that question. So now next problem I will take. So I will take another problem, complicated problem. I will take another problem. Okay? So first of all, make it clear or not? Simply. So now next problem is, I have taken another problem. Here current source like that one, a resistance connected like that one. After that, a resistance connected like that one, a circuit here, and another resistance connected like that one. Here again a current source like that one, a resistance connected like that one, a resistance, after that resistance, and here voltage source. Okay, so that one plus minus. Now that one is 132 ohm. Okay, 132 ohm. That one is 264 ohm, and that one is 88 ohm, and that one is 44 ohm, and here 1 ampere, and here 5 ampere, and here 10 ohm, here 110 volt, and that is 12 ohm. Okay, our motto, determine what about that value, plus minus Vx, and here plus minus Vy. Okay, so basically our motto, determine nodal, with the help of nodal analysis, what about Vx and Vy using nodal analysis. Okay, so first of all everyone try. First of all, everyone try. Then I will do. Then I will do. Okay? First of all, everyone try. Then I will do. Simple, using nodal analysis. So, okay, first of all, decide branch current. Okay? First of all, decide branch current. Okay? So what about branch current in here? We have considered I1, here I2, I3, I4, I5. Clear? Clear or not? After that, node voltage. Here V1 and that one taken vector node. So I have already discussed. What about that voltage, that is Vx? If this one is Vx, that's also Vx. Okay? Now, what about that voltage? That V1, Vx and here V2. Clear? If anyone faced doubt in any step, then tell me, sir, I explain again. Otherwise, I will explain again. Clear? So first of all, apply KCL. Apply KCL at node Vx, V1 and V2. If you see very carefully, 1 ampere outgoing current, 1 ampere plus 5 ampere plus I3, this will equal to 0. So what about I3? Basically how much? 6 ampere. Very simple. Very simple. If I3 is 6 minus 6 ampere and I3 is also written as Vx minus 0 divided by 44. So if that value put here, then we got Vx. Vx is how much? Minus 6 into 44. So Vx is minus 264 volt is the right answer. No. Basically this is Vx. Basically this is Vx. That's how much? Minus 264 volt. Okay? If anyone faced doubt, then tell me, I will explain again. After that, apply KCL at that node. Apply KCL at that node because we are focused on Vx. Okay? Incoming current 5 ampere. Outgoing current I4 plus I5. I4 is how much? V2 minus 0 divided by how much? 88. I5 is written as V2 minus 0 current leave from negative terminal, so minus 110 divided by how much resistance? 10 plus 12, that is how much? 22. Okay, take LCM, then we got V2 plus 4 into 4V2 minus 440 divided by 88. Okay, then we got how much? 5 into 88, this is equal to 5V2 minus 440. So what about V2? V2 is basically 440 plus divided by 5. So 880 divided by 5. V2 is how much? 156. 156 volt. V2 is how much? 156 volt. 5 1 ja 5. 5 1 ja 5 3. So shit. Silly mistake here. 5 1 ja 5. 3 8 38. 5 7 ja and 5 6 ja 176 volt. Okay, sometimes silly mistake, then your answer is wrong. Okay, so recheck again. After that, V2 is how much? 176. Okay, now next target is how much? That current, I5. If you focus on I5, I5 is written as I5 is V2 minus V2 is how much? 176 minus 110 divided by 22. So 60 no. 6 7 minus 1 6. So 66 by 2 22, that is 3. I5 is how much? 3 ampere. After that, current direction like that one, but polarity corresponding to here. So minus Vy is equal to 3 into 5 10 into I5. So I5 is 3, so 30 volt. So Vy is minus 30 volt. Is the right answer. Make it. Okay. Clear or not? So Vy basically how much? So finally we got Vy this equal to how much? Minus 30 volt. Okay. So finally Vy is equal to minus 30 volt. And Vx is, and what about Vx? Vx is how much? Okay. I hope so. Okay. Basically, our motor determined with the help of nodal analysis. So using nodal analysis, not using another method. Someone say, wait. Someone says, sir, why not using? Because in question is given is the same as going in closed loop. Kirchhoff's second law. No. Only apply KCL. Okay, because the question mentioned using nodal analysis. So if question say using nodal analysis, so using nodal analysis, not other method. Otherwise, you can solve this question lot of methods. Source transformation, Thevenin's equivalent, Norton equivalent. Okay, KVL, source transformation. Okay, current division of voltage division, whatever, lot of methods. That's why. So if you say simply using nodal analysis, so using nodal analysis. Okay. Thank you for comment. Any doubt? If you face any doubt, then tell me. Comment it. I will discuss again. Okay. So I will explain again. Okay, in very short. what can do? Simply question say our motor determine that voltage and that voltage. So first of all, and also this question do with the help of nodal analysis, means basically application of KCL, using KCL, not KVL. So first of all decide branch current I1, I2, I3, I4, here I5. After that node voltage V1, Vx and V2. So our motor determine that voltage and that voltage. So that's why we are focused on that node. Apply KCL. Then we got knowing this one and this one are going 1 plus 5 plus I3 this is equal to 0. So what about I3? I3 is how much? Minus 6 milliampere, minus 6 ampere. After that, what about I3? I3 is basically Vx minus 0 divided by 44. So we got that value, we got Vx this is equal to minus 264 volt. Vx is minus 264 volt. After that, incoming current at the node 5 ampere this is equal to outgoing I4 plus I5. I4 is how much? I4 is how much? V2 minus 0 divided by 88 plus I5 is how much? V2 minus 0 currently from negative, so minus 110 divided by how much resistance? 10 plus 12, that is 22. Okay, after that solve, we got V2 is how much? 176 volt. Okay, so Vx we got 176 volt. Now next target is determine I2, sorry, I5. Our motor next target is not Vx, Vy. So how can we determine? Simply apply KCL at that node. Okay. We got after then we got V2 is how much? 176. So our motor determine I5. If you determine I5, then we got how much? 3 ampere. But if you here current direction in this branch minus plus to minus, but that polarity is given minus to plus, so minus to plus minus Vy this will equal to current leave from here to here in this direction, and so 10 into I5, and I5 is 3, so we got 30 volt minus Vy this will equal to 30 volt, so Vy is how much? Minus 30 volt is the right answer. Okay, I hope so your doubt is clear. Now next I have taken another problem also. Okay, now basically this question is question number 16. Okay, question number 16. Now what about that question? That is plus minus. After that a current source. After that is 6 kilo ohm, and that one is 5 kilo ohm. Minus plus, and that one is V naught. And that one is how much? 6 milliampere. That is plus minus 5 volt. And that one is 2 kilo ohm. And that one is 6 kilo ohm. And that is 3 kilo ohm. And here minus, here plus, and that one is 6 volt. Our motor determine V naught using nodal analysis. Using nodal analysis. Okay, so first of all try everyone. After that I will do. Okay, First of all, try everyone, then I will do. Okay? If anyone faced out in any step, then tell me, I will discuss again. Okay? If anyone faced out in any step, then tell me, I will discuss again. Okay? Now, so our motto, using V naught with the help of nodal analysis. So how can do? How can do? First of all, nodal analysis say decide branch current. Here I1, here I2, and that current also going in this branch, and that one is taken reference node, and that one is V1. Okay. If that one is 0 voltage, that is also 0 voltage, and this one is V naught, so that point voltage also V naught. Clear or not? After that, apply KCL at that node. Apply KCL at node V1. So incoming current 6 milliampere, outgoing current I1 plus I2. 6, this will equal to V1 is written, I1 is written V1 minus current 0 and currently from negative to so minus 5 divided by how much? 2 kilo ohm. I2 is how much? V1 minus currently from plus 6 positive term, so plus 6 divided by how much? 9. Okay, 6 plus 3 both are series. Now 6, take LCM, 9V1 minus 45, 2V1 plus 12 divided by 18. So 9 plus 1, that's 11. 11V1, this will be equal to 108 minus 12 plus 45. So V1 is how much? 108 minus 12, that is 96. 96 plus 45. One we usually call C. Silly means 144. 141 divided by 11. Then what about that value? 141 divided by 11. That is 12.8 volt. Okay. Our motor determine. So what about I naught? Sorry, not I naught, I2. I2 is written. Our motor determine V naught. So simply, so first of all make it. I will explain. Okay. I2 is written here. I2 is written here simply V1 minus V2 or V0 divided by how much? 6. This will be equal to, this I2 is written as V0 currently from how much? Which terminal? Positive terminal, so plus 6 divided by 3 kilo ohm. Okay. After that, V1 minus V0, this is equal to 6 is going on here, and 6 by 3, that is 2. 2 V0 plus 12. Our target is V0. So 3 times V0, this is equal to V1 minus 12. And V1 is 12.818 minus 12. So V0 is 0.818 divided by 3. Then what about that value? 0.818 divided by 3, that is plus 2.7 to 0.2726 volt is the right answer. Make it. If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt corresponding to any step, tell me, sir, I faced doubt, so please explain. I will explain. Okay? Your valuable feedback is very important for me. Okay? So comment it. Sir, I feel understand about now. You understand or not? If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt, then tell me, I will explain again. If anyone faced doubt, then tell me, I will explain again. Okay? Anyone faced doubt, then tell me, I will explain again. Okay? So final answer is how much? Now, if your doubt is clear, then how can do? First of all, our motto, what is our motto? Determine V naught. Okay? So we have decided branch current. Here I1, here I2. Okay? After that node voltage, this is node voltage V1 and this one is V naught. Why? Because of this one is 0 voltage and that is V naught, so V naught here. Simply. I have already discussed why, because of in previous question which proof in that voltage given V naught or whatever be the voltage here, then if this one is 0, so this minus this, okay, this minus this will be equal to this minus this will be equal to V naught. So if this one is V2, V2 minus 0, this will be equal to V naught, so V2 is equal to V naught. So that's why that voltage is V naught. Clear? After that, apply KCL at node V1. Incoming current 6 milliampere, outgoing current I1 and here I2. I1 is how much? I1 is how much? That is I1 current. V1 minus 0 current leave from negative sign, so minus 5 divided by how much? 2 ohm. Plus, what about I2? I2 is V1 minus 0 current leave from positive sign, so plus 5 divided by 6 plus 3, that is 9. Okay, after solving, we got V1 is how much? Like that one. And what about I2? I2 is written V1 minus V naught divided by 6, and also I2 is written V naught minus 0 divided by current leave from positive sign, so plus 6 divided by 3. After solving, we got V naught is equal to how much? Like that one. And that one is the final answer. That one is the final answer. Make it. Okay? So, I hope so. Your all doubt are clear corresponding to nodal analysis. So, if anyone fail doubt or in any step corresponding to nodal analysis, then tell me or comment it. I will explain. Okay, I will slowly explain. Okay. So now today class is over. Okay, thank you very much for joining me. Tomorrow I will take some another problem corresponding to nodal analysis. Okay, so thank you very much for joining live class. If anyone faced doubt in any time, then you can WhatsApp me 919041398104. WhatsApp me your problem. Okay. Thank you.